My name is Sabina Shaikh. I am a member of the faculty here in CEGU, the Committee on Environment, Geography, and Urbanization at the University of Chicago. I just wanted to give a quick plug that we're going to have our annual conference next week, Thursday and Friday, at the International House, Past and Future Commons, and we'll be addressing a lot of different topics, including some of the very compelling themes that Carlos brought up in his talk. So just want to invite everybody to that. I also have the great fortune of serving as the co-lead for the Environmental Frontiers Initiative at the Mansueto Institute, which is very closely aligned with a lot of the topics that are being discussed here today and involve a lot of students in that work. So I wanted to thank the Mansueto Institute for hosting and supporting such important initiatives around environment and climate at the university. I also wanted to reiterate what Emily said in thanking the Mansueto staff. So Amy, Brian, Elaine, and Heidi, who go really above and beyond in everything that they do and they support here, and who are also just great friends. So thank you all. I also just wanted to quickly thank the Emily, Chris, and the Kreismans for hosting this initiative and the symposium today. There's really hasn't been a conversation like this on campus, so I think it's extremely important, and I'm glad that you're all here. So without further ado, I will say that I had the great fortune of introducing today's speaker about 8 or 9 years ago when he gave the keynote talk at the what was formerly the OI here. So I'm not sure why I keep getting asked to introduce Dan, but I feel very lucky, and maybe I'll get to do it again in 8 years from now again. So with that, Daniel Kammen is the class of 1935 Distinguished Professor of Energy at the University of California, Berkeley, with parallel appointments in the Energy and Resources Group, the Goldman School of Public Policy, and the Department of Nuclear Engineering. Yeah. He was appointed the first Environment and Climate Partnership for the Americas Fellow by Secretary of State Hillary Clinton in 2010. Dr. Kammen is the founding director of the Renewable and Appropriate Energy Laboratory, co-director of the Berkeley Institute of the Environment, and director of the Transportation Sustainability Research Center. He has founded or is on the board of over 10 companies and served as the state of California and U.S. federal government in expert and advisory capacities. So with that, I will turn it over to Professor Kammen, and then I'll be back before the Q&A. Thank you.
Well, thank you so much for the introduction, and I want to thank everyone for tolerating a remote speaker. And I guess before I go on, I should just make sure that the sound is good with no feedback or anything. Okay, I guess I'll go on unless someone objects. It does always feel a bit strange to be the disembodied when you guys are having lunch, so I'm hoping that there'll be a way to make the Q&A particularly interactive. I will just jump in, but again, if you can't hear or if something is obviously jump in and let me know. So what I wanted to talk about today was the housing story from really the perspective of an energy scientist. And I hope what that means is that I'll start off with what I would regard as the conventional approach, and then over the 30 minutes of talk, get more and more unconventional to try to stir some debate. And so my affiliations at Berkeley really span from an interdisciplinary energy group to our School of Policy and the School of Engineering. So quite different communities, and I'm hoping that that comes through a little bit in the conversation. My slides and the other materials are available on the website of my laboratory, which is RAIL, the Renewable and Appropriate Energy Laboratory. And for those not sufficiently turned off by Mr. Musk and his dealings on Twitter X, it's just listed under my name, Dan_Kammen, if you want to comment or anything. And I'd be, again, any form of feedback and discussion would be interesting and appreciated for the things I'm going to say. So I want to start off with what's the most conventional picture. And hopefully this is familiar in some form to everyone here, with the black line at the left showing the linear or exponential, depending on your mathematical worldview, growth in greenhouse gas emissions. And then these series of colored fans or lines representing the different policy worlds that we're in, depending on how optimistic or pessimistic you are. From the top light blue, the current policies that would only limit global warming to 2.5 to 3 degrees Celsius. That's where we are today. If we take the more aggressive pledges and targets proposed in the US, in China, in Europe, in a variety of places, maybe you get down to this darker blue band where we would limit the warming to about 2 degrees Celsius. And that was the target that the international community was aiming for pre-Paris, and that's now 9 years ago at COP21, since we've now passed COP28, the climate conference, and really to recognizing that the green path that goes carbon negative a bit after mid-century is the path we need to be on. So if you kind of qualitatively think about this fan, this kind of policy fan of options here we see with the different policy scenarios. A number that's going to come up in the talk later on is that we are failing by a factor of 3 or more. And again, I'll come back to that in a bit. And that really means we need to be in the 1.5 range, but we are at 3 or more now. And that's going to come back in terms of some very important milestone documents that President Biden and President Xi of China signed in November. And again, that will come up quite a bit as we go forward. So as we think about that sort of that wedge, the most conventional path that I'll describe in the first few slides is, well, we need to get busy with making clean energy cheaper than fossil energy. And if I was giving this talk 20 years ago, that would have seemed kind of bold. That's now in the past, and I'll illustrate that in the next few slides. And so really why I was so excited to attend even remotely for the meeting was the conventional theory of change is really you start off with solar panels on the White House. There's a young President Carter with a bunch of very 70s hairstyled individuals putting solar panels on the roof of the White House, passing what until President Biden was the most aggressive piece of climate policy the US had seen. And of course, these solar panels on the White House were then removed by President Reagan. They went to Union College. They had a very interesting path. But the conventional path is we start here, we invest money, first public sector, then private sector, we scale up, and essentially this technology is available for the rich, hence the middle picture of a futuristic home. And then it trickles down to everyone else. And so we see solar on lots of rooftops. This is actually a picture from a Chicago suburb, and I'll come back to some of these numbers in a bit. But no matter how much you believe in this kind of trickle-down theory of technology and innovation, it is clearly far too slow to meet the climate goals of being carbon neutral mid-century. That's not surprising, but what I think is surprising is that we still depend so much on this very neoclassical view of technology innovation. And so really, if there's one message or one plea from this talk, it's can we do away with these conventional theories of change, and can we find a way to do this instead? Can we jump from normative good ideas into mass distribution so that justice and equity are co-equal with climate or other issues? And this really is the heart of what I want to try to illustrate today. So I'll spend the first 10 minutes doing the conventional, and that's this march through where solar panels or electric vehicles for the rich come first, and then they somehow get cheaper, and that ultimately we all benefit in some very slow way where the rich are in the exciting policy world of the future, and the poor get the dregs down the line. And I say that as the co-director of Berkeley's Center or Roundtable for Climate and Environmental Justice, which again will be a key part of my comments later on. And the reason why I think it's worth saying this, which is because obvious to everyone, is that even our best policies, I would argue, the Clean Air Act is one that might have found an interesting, unique route, but the Inflation Reduction Act, certainly the most interesting and aggressive, although certainly sausage-made piece of policy we have recently in climate, would essentially take the current rate of greening the economy or decarbonization, where we reduce emissions by perhaps a third. I don't know if that feedback was something I should be. Uh-oh. Something just changed, it seems like. I'll keep talking, but if I'm hearing the feedback myself. I don't know why, because I have nothing else on. All right, I'll keep going, and you tell me to stop if there's a problem. So essentially, we were on a path by 2030 to have cut greenhouse gas emissions across the U.S. by about a third. And the Inflation Reduction Act, $369 billion invested in the space, would increase that to, at the most optimistic, cutting by about 44%. And that's, again, taking the range here. And so it's a wonderful policy. I'm a huge fan of many things in IRA. I'm not a fan of a few subsidies that I believe are too big. Well, won't get into that today. But essentially, this is a trickle down, but a very nice picture of a trickle down set of policies. And what it leads to are some interesting features. Making solar panels, making batteries, making electric vehicles cheaper. That's all good. But I do want to highlight that as we delay action in the greenhouse, it's not only bad for crops, for plants, for asthma, but it's also bad for the transition. And so here's a picture of my rooftop here in Oakland, California, on a day like today, a wonderfully clear springtime day. But here is during the climate apocalypse or the Mad Max season. I'll turn down the speakers a bit. But here is a picture during that climate apocalypse season that we get in that new fire season. You can see the skies turn Mad Max orange. And if you look at the output of my solar panels, here is a typical day when the sky is clear, but you can see it goes from output of about 1,600 watts down to 0 on these days of just gray sky. And so not only does climate change cause ecosystem damage, but it also thwarts the energy transition. And so we're going to have to deal with those surprises in the greenhouse as we go forward. And one of the questions then is, how do we get out of this worldview where clean energy is available for the rich first and often only, and that this trickle-down process is highly unsatisfying and ultimately doesn't get us where we want to go because we're so far behind schedule. And really, that's the core of this talk. Inflation Reduction Act would perhaps triple the amount of deployed solar, double the amount of deployed energy storage, a lot of it in distributed homes and businesses, we hope, but it would not get us where we need to go. And unfortunately, what that means is that we end up spending a great deal of time worrying about lots of other issues, which are essentially going to become rearranging deck chairs on the Titanic if we can't get our industrial clean energy policy in place. California, I know people and almost everywhere else are tired of hearing about California because we do talk way too much. But there's a couple elements of California's policy that impact on housing and have had some interesting steps forward. And so California originally said 20% of our energy from renewables by 2010, a target we missed. But getting the deployment going meant that we made that target 3 years late in 2020. And our target for 2030 was to be 1/3 powered by renewables, a target we blew past. So we missed the 2010 target. We made the 2020 target 3.5 years early. Our initial target for 2030 was to be half powered by solar, wind, geothermal, biomass, if it's sustainable. And notice I didn't mention large hydro or nuclear because they're not included in the portfolio. But what it's meant is that the policies have gone so quickly that our 2030 target is to be 60% powered. And as you'll see, we're even beyond that today. That's fine, but that's not good enough because the pace of climate change is picking up so dramatically. And so one of the concerns is, how do we accelerate this? And one of the areas that I saw some interesting comments on earlier was thinking about integrating electric vehicles into our building stock. And again, California's policy with aggressive clean energy includes a very healthy dose of electric vehicles. And I'll come back to that twice over in a bit. So the piece of trickle-down policy, which has been our best friend, has been to notice that the more we deploy mass producible technologies like solar panels, batteries, not large centralized technologies like, say, nuclear power plants or aircraft carriers, is that their price falls very, very predictably. And notice this log graph is showing price versus total installed capacity. Time is just a stamp along the curve. And while today is now 2024, the price of solar is now, in the best cases, 3 to 5 cents a kilowatt hour. And that means that this learning by doing, Moore's law, Swanson's law, has meant that solar went from the most expensive technology just before I started my university education to now the cheapest. And now this amazing statement is true, that it's now cheaper to build a new clean energy power plant than it is to operate an existing fossil plant. And that has been the amazing story. Here's the exact same curve for energy storage. This is lithium-ion batteries, obviously cell phones and laptops, electric vehicles, and then a whole variety of other technologies, so-called flow batteries, larger battery systems, not for mobile use, not for cell phones, but as part of the power grid. Same picture, price versus total capacity, showing these dramatically reducing cost curves. And they mean that for these technologies that we can mass produce, wind, solar, and batteries, that we see roughly a 20% drop in price every time we double the number of them installed. And that learning curve has really been our bread and butter in making technologies cheaper. What it hasn't done is leverage what this conference is about, and that is thinking about creative applications where we can link clean energy, better quality, and lower cost housing, which sounds like an impossible dream, but I'm going to argue as we go forward that actually it's entirely possible. And the reason why I say it is that when we look at the emissions burden around the planet, the richest 1% of the population are more than 15% of greenhouse gas emissions. The richest 10% are more than half. The poorest 50% of the planet are less than 7% of emissions. And so if we don't find a way to make justice a co-equal partner with clean energy, then we fall into that horrific William Gibson world where the future is already here. It's just not evenly distributed. And that means that we are fighting what ultimately has to be a market-based battle, only with subsidies, only with Inflation Reduction Acts. And we know that will not give us a full economic transition. So an example of this is a big machine learning AI project that I did with two former postdocs, now both professors, Deborah Sunter at Tufts, Sergio Castellanos at Texas Austin. And we simply looked at every single solar panel across the country. This was data up to 2019. And what you see is that if you look at who has solar on their rooftop, so a lot of machine learning, a lot of kind of cool stuff for my computer science friends and students in my lab, where we essentially look at solar panels on rooftops, identify them and tell them apart from other mechanical devices, use some machine learning, pull out pictures where the rooftops are, and then correlate it with neighborhoods. What we find is a horrific story. And probably the first part won't surprise anyone, but hopefully the second part will. And that is, if we categorize neighborhoods across the country as one majority group based on 51% or more, either no ethnic majority, or if you're over 51%, any given group have categorized them. So starting with the green line in the middle, what this shows is that in communities, these are not zip codes, they're often down to the census tract level, that if you look at the green for areas with no ethnic majority, what we see is across a full order of magnitude of income from below the poverty line to about $200,000 a year income, that if you are in a white majority neighborhood, solar is about 40% more likely in that undifferentiated or that green area. If you are in a Hispanic or African American majority neighborhood, solar is about 50% less likely at the low end, and it gets even worse. So in African American majority neighborhoods at the high income level, there's not many of those, we see that solar is almost 75% less likely than in the undifferentiated, and therefore vastly less than in Caucasian white majority neighborhoods. And so that really gives you a feeling for the degree to which the way we've installed these new technologies follows a lot of the same biases, redlining, lack of access to capital, lack of helping new innovative companies launch that we see in a lot of other areas. And so a piece of President Biden's Justice 40 initiative to put 40% of federal infrastructure spending into underserved, marginalized communities is to really take a look at, will we just simply repeat the errors of the past, but with new technology? And hopefully, of course, the answer is no. And what I'm going to argue is that we have some tools to think differently. The first one is that clean energy costs have fallen dramatically, and that we are seeing that in some of the places that have taken the most aggressive path. So 2 years ago, California, briefly in the springtime, was able to meet almost all of its energy needs with renewable energy. And the springtime was when we have the best weather. We have relatively good wind, we have excellent sun, and we don't have the very hot air-conditioned driving temperatures and the fire damages that we see in August. And so that's a great start. I won't dwell on it, but only to highlight that if we jump ahead only 2 years to today, last Saturday, April 20th, what we saw in California was really where we need to be going across the country. And that is California met 147% of its total energy demand with renewables, 122% of solar alone. So yellow is solar, green is wind, large hydro is in there, although we don't count it as a renewable. And this dark blue is the new entrant, and that's batteries. And so what we're seeing is now there are no more subsidies for installing solar only in California, but there are subsidies if you install on your home or your business storage in solar. And so what you're seeing here is not a lot of use of it in the middle of the night. Supplies are pretty good, but late in the day, dark blue storage really comes on strong, and it now is playing a role of essentially an additional source. And of course, if that storage is powered up by renewables, it is meeting this kind of new picture of lots of dispatchable energy technologies, unlike the world of 30 years ago, where these lines would be straight baseload quantities of coal and gas and nuclear and hydropower. And so what this led us to in terms of housing is starting to look in detail at what is the carbon footprint of homes and neighborhoods as a way to track how well we're doing. And so we have a very active project called Cool Climate. We frequently run competitions across all California or all Oregon universities or schools to see what is your carbon footprint. And we have various web and app-based tools so you can basically do a carbon audit. Your energy signature is a big piece. Your transportation is another. The carbon footprint in food and the packages delivered to your home or office all go into that. We've gotten some very useful interactions and coverage through some big New York Times spreads about carbon footprinting neighborhoods, and they can tend to look something like this. These are carbon footprints with the greener colors, low carbon, the darker colors, higher carbon. And you wouldn't even need to do any analysis to recognize the obvious point, and that is that higher property values, more mass transit in urban cores tend to lead to lower carbon footprints, be it Chicago or New York or wherever else. And so a lot of this kind of tracking of your carbon footprint leads back to what is the physical footprint of your transportation energy needs, but also what's the embedded carbon in the choices you make in terms of housing materials, in terms of goods and services delivered, et cetera. A kind of an example of this project where we tried to take on directly the housing challenges for low-income neighborhoods is a project called the Oakland Eco Block. It's got a range of private sector partners and laboratory partners. And essentially what it is a 2-block area in a low-income part of California. There is the 2-block area And what you see is got apartment buildings, it's got a number of single family homes, some rental homes, quite a number of grandmother units in the back. And instead of just doing this as a series of individual actions by individual families, this was a block that agreed to take part in a pilot where they formed a homeowners association. One homeowner was willing to donate their garage that became the house that has become the hub of a series of batteries. And so solar that goes on the rooftop is going to power up the batteries in this former garage, and then power is sent back to homes. And actually, the community spent almost a year and a half deciding how power would be sent back. In a very interesting partnership where you get power based on what you used before, but also innovations you put in. So this 2-block area is one that is now set up to have public EV charging with Zip cars on the street. And so you don't need to be a homeowner. You can park your electric vehicle on the street and charge up. But there's also going to be some block-owned Zip cars available that are charged up. These are all electric vehicles. And again, you can see in blue all of the solar rooftops. And again, it's not direct feeding to the home. It all goes into central batteries and then goes back to the community areas. And so this project has generated a lot of interesting conversation and dialogue. France and Amsterdam, Paris and Amsterdam are doing versions. So there's a lot of partnership about how do we make this process easier? Because it took us years and years to get through the paperwork with utilities to make this happen. We have some very unconventional batteries. We are using a flywheel battery system in that garage, as well as some conventional ones, to test out new technology, but also to go to lower carbon materials and kind of a better justice footprint in terms of getting away from the cobalt that's involved in lithium-ion batteries. These are actually just graphite flywheels sitting in tanks here. So an example of trying to make the innovation hub a low-income community and not a trickle-down version. And what this has meant is that in places where there is an aggressive clean energy market, the world is really changing. You saw on that curve that storage was now part of the equation. And so here is the gigawatts of energy available to dispatch in the California region. And so what you see here is that while the real-time price of power goes up and down, we're charging batteries when the sun's available. And so batteries charging is in pink, or I guess that's fuchsia maybe. And then at the end of each day, you can see power coming out of the batteries, and that's blue. So here we have a place where not only clean energy, but energy storage and distributed storage, so that my home in Oakland, California, has solar on the rooftop, and I have a stationary battery in the garage. I also have an electric vehicle, which is not yet allowed to participate, which is one of the reasons why I was so keen to talk to this group here. And what this means is that we have seen some dramatic changes really due to clean energy. So with a great deal of wind on the grid, even the formerly traditional Texas has hit zero marginal cost electricity. In the US West, this is just a month ago, we've seen prices go negative. And in the East, prices quite well constrained. And this is far less than people would have forecast prices would have been without renewables and storage on the grid. So kind of some dramatic opportunities and changes. Now, as we kind of think about not only the housing footprint and why we need to do much better, and why the energy community really needs to engage on real estate and other issues very directly, here is what I meant by this tripling issue. And this is the agreement that President Biden and Xi signed at the APEC conference in November, the so-called Sunnylands Agreement. You know, they looked long and hard for a city to have the meeting with such a good name as Sunnylands. What this was a commitment for the US and China to work individually at home and work together internationally to triple the amount of renewables deployed. And the reason why that's both an interesting target and one that should depress you is that if we look at the growth in clean energy, which has been doing wonderfully well over 2023 and 2022, in each year, more than 90% of new energy capacity installed anywhere in the world was renewables. If you project that forward, you can see China is a big player, US is a growing player, Europe is second largest after China in terms of clean energy. And if we just extend that curve forward, we get to this bottom, this end of the gray bar here. That's impressive growth, but tripling renewables deployed would require this extra green bar. And in a wonderful coincidence, what that means is that the amount of extra green energy we would need to make good on the Sunnylands Agreement, which is an agreement consistent with that deep decarbonization, that 1.5 degree target, we would need to install, even beyond the current aggressive growth, an amount of green energy equal to the world's installed capacity in 2022. So that just shows how massively we're falling short and how massively we're going to have to leverage real estate and electric vehicles and a whole variety of new technologies to get us there. And again, that was the guts of the Sunnyland Agreement. There's the presidents walking through Golden Gate Park discussing this at the APEC summit. So where do we go from there? Well, we're going to have to think very differently about installed capacity. And so one version of that is, how can we incentivize green energy in a distributed, housing smart way? And so an example of that is a project that we did for New York City. And what I'll show you is a very quick simulation of taxis in New York City. And what we simulated here is that if every single taxi in New York was electric, what would you need to do in terms of distributing those resources? And so every red dot here in Manhattan is a taxi with a rider. Every blue dot is a taxi that's empty looking for a rider. And so this is going to be a 15-hour simulation starting at midnight, and I'll just run it forward. See the taxis moving around, and as we get, and so these green dots are where people are charging at their homes or apartment buildings. As rush hour hits, you'll see a flood of empty taxis. There it goes, flooding into Lower Manhattan. And as the day goes on, people are now going to want to charge in Manhattan. So you see green dots appearing, Lower Manhattan and Midtown, where those taxi drivers want to recharge so that they can maximize their revenues and maximize the use of these EV taxis. And so we did this for New York City. They promptly thanked us. We wrote a report. Nothing came of it. We sat down with China's EV leadership group, and they rapidly adopted it. And so what China did was to essentially take on the challenge of getting to clean energy. And what we now have in China today is a remarkable situation where there's about 17 million electric vehicles in use in China today. That's at least twice what they thought it would be if you look at the forecast only a few years ago. And to put it in perspective, the US has about 2.2 or 2.3 million electric vehicles, trailing now the UK. So we work closely with partners in China to look at how could you power up all those electric vehicles, some large power plants, but a great deal of distributed energy on apartment buildings in rural areas and communities to put all that energy into place. So here's an example of taking the data from New York City that I showed you and putting it into operation, which is exactly what China did. So what they did first in the city of Shenzhen, a very, very innovative, creative city, of course, in the south next to Guangzhou near Hong Kong, was to, over 1 year, replace all of the gas-powered taxis with EV taxis made by their hometown company, BYD, or Build Your Dreams. And they may have a gender problem in the taxi drivers, but what they did overnight was to replace, again, 31,000 taxis with EV taxis. And they, of course, immediately had the classic congestion problem. Here we have those taxis, and I'll play this video, but nothing happens. These are those EV taxis queuing up for hours waiting to recharge, which, of course, angered everybody. So what you do in this situation, of course, is you build an app. There's the app that basically informs drivers where there are spaces available to recharge. This was at the time the largest EV taxi bay, EV recharging center in the world of 600. I now know there's a bigger one in another bigger one in China, and Los Angeles is planning on more than 600 EV charging bays at LAX airport alone. So building the app and informing drivers where the best places to recharge are was one part of the story, but it gets bigger, and this is really where smart city planning comes into play. Here is the current effort underway in Chengdu, China, city of over 20 million, where electric vehicles, both public vehicles, taxis, and private ones, are coordinated with the mass transit system, with electric bikes, with the train system, and you can see those across here. Bike ownership, taxi ridership, and so essentially tying this together, giving information and credit to those that are able to complete trips using all green energy or new energy vehicles in the Chinese parlance. And I say that because one of the real challenges here is not just to replace traffic jams of gas-powered vehicles with electric vehicles, but to be able to think differently about the planning part of the story. And really, that's where distributed real estate assets, whether it might be free charging or free access to vehicles if you bring and return an electric vehicle at a subway or a mass transit hub, perhaps charging inversely proportional to income. There's a variety of tools that could leverage real estate as an asset for both energy storage, batteries, and charging. And again, these are the pieces of a smart green future we're going to have to put in place. Because I promised I would stop at the top of the hour, I'll skip a small case around power systems in across Africa, but really just want to highlight that what I wanted to cover here was that housing and transportation really is a climate justice story. Long commuting times vastly hurt low-income individuals, not finding ways to essentially capitalize rental and other properties with charging, with opportunities to deploy green energy. Hurts everyone, and in particular hurts the poor. And that if we can think about more mechanisms like the ones I've tried to highlight here with the eco block, with powering taxis built into real estate, these are all opportunities to dramatically accelerate that curve, where overall we're going to have to find ways to make radical that new normal, because we are currently not on pace to get there with this kind of the old style model of trickle down processes. And so again, thank you so much for letting me present remotely. I hope it worked over Zoom and with lunch. I'm going to turn it back for the Q&A and discussion part. Let me stop sharing the screen and just try to make it as discussion oriented as possible. So thank you all for listening.
Okay, thank you so much, Dan. For the Q&A, I just want to let everyone know that Dan's view is that camera back there. So if you would like for Dan to see you while you're asking your question, which would be great, if you could face that camera back there. And I will start with Emily Talon.
The camera coming in. Dan, thank you so much. I'm sorry you didn't get a chance to be here, but we have a pretty full room here, and you came across perfectly, so thank you. I have a question that might be slightly off topic, but I really want to get your thoughts on geoengineering. Because the University of Chicago has recently decided, well, maybe, I don't know how recent it is, but they're pouring money into that. And I just wanted to get your overall thoughts on that as a strategy.
Oh my, okay, so it's certainly not a housing strategy. And unfortunately, I do know the U of Chicago decision quite well. Your president and I are co-authors on a couple papers on solar, and the individual that you recruited to run your geoengineering program is actually a kind of a close friend, someone I know well. So quite a challenging topic, and I have to admit, I am not a fan. And I'm not a fan in the sense that I don't think we're going to need it. I do believe we are going to need to capture carbon and geoengineer in the sense of finding ways to reflect sunlight back or capture carbon directly out of the air, so-called direct air capture. All of these are tools that I unfortunately think we're going to need. But for everything I showed in the talk, the rapid price declines we've seen for clean energy mean we are just crossing into the world where we can now deploy in large amounts, make these technologies better, find ways to make our clean energy deployment a justice first strategy. We just ticked into that category. And in my view, unfortunately, moving to these climate engineering approaches, while technically sweet in the kind of term of Oppenheimer, are ones that mean that we would likely give a longer life and a bigger lease on life to fossil fuels right at the point when we could be replacing. So I wish I could be more positive. Again, I do think we're going to need it. We are going to ultimately do these things, but this just feels absolutely like the wrong time frame to do so. And again, it feels like a technocratic solution to a problem which is inherently a social one.
I'm turning this way because I was told to turn this way.
And I see you well. Thank you.
Hello. You're probably too young to know this, and I'm sure almost everybody I see in this room is too young, but in the 1970s, there were articles being written about the coming ice age, that they were predicting that the ice age would in fact pour down through Canada and maybe cover cities like Chicago. Doing a little brief research here, I see that the climate temperature around the world has risen since 1901, according to what I was reading here, because I don't know how accurate it is, by less than two degrees. So my question to you is, what exactly are we fighting? What exactly is the harm? I mean, I know people who go down to Florida in order to get a warmer climate during the winter. So what's wrong with a warmer climate? Why is that, even if we're causing some of it? Why is it so terrible?
Okay,
I'm
so
sure you got some good answers,
right, so
but
we
that's
are
why I asked
certainly
the question.
causing it.
Thank
The
you.
world has warmed since the 1950s about 1.2 degrees. That every single tenth of a degree causes huge harm. We are essentially a species adapted for the world we used to be in that we have thrown out of kilter. And so when you look at the fires in California, in Siberia, in Australia, in Greece, these are all ecosystem disasters in terms of the trillions of animals, but also in terms of ecosystem transformation. The damages we see in terms of heat waves, Siberia, as you all saw, hit over 100 degrees Fahrenheit recently, massive feedback effects in terms of climate damage, large-scale tree deaths. So the climate damage of the world we're in is one where if you think in terms of well, a degree here and there doesn't matter, it's actually on the order of tenths of a degree matter dramatically. And the biggest effects we have not yet even seen. The disasters for the food systems that are coming in the greenhouse are ones where each tenth of a degree average change completely changes the growability of different foods, the demand for water. We have seen now the Mississippi, the Yangtze, the Danube, the Yellow River, all drying up. These are all features of not only climate change, but anthropogenic drawdown. So the climate damage story that we're in for that small number of degrees is actually overwhelming to both our ecological state, but also to our built environment.
Hey, disembodied Dan, will you help me change my opinion? So your first slide had it, the Carter to the prestige solar to the very common for moderate income. I'm of the opinion that we cannot skip from FERT 1 to 3 because new tech has to be a prestige good that is non-economic until the tech can iterate enough that it's cost effective. So how do we scale a solution really quickly going from the Carter to tossing it onto every home? If we'd done that back then, it would have not made sense.
Yeah, so I mean that's what I was sort of trying to illustrate through the slides, and that is there is certainly that sort of conventional pathway of the rich get it first and then the poor get it far later. But I think the other key aspect is that we generally do not innovate for they, meaning that the first solar panels were the highest efficiency, most exotic, they were not ones that were designed to be integrated into the buildings of low-income developments. We now have a far larger range of not only solar cell materials, but battery materials, opportunities to do low cost first, not high cost and then push the price down. And by that, I mean our materials choices dramatically impact that. So let me give an example in the battery space. Currently, the batteries in all of our cell phones and laptops and our electric vehicles are lithium-ion batteries, which involve cobalt. And we've known that, and cobalt is currently the worst of the offenders in terms of environmental and human rights abuses where it's mined, primarily in the Congo, where I work extensively on these topics. A fairly simple shift, and actually this is the paper that your president, University of Chicago, and I wrote together, was let's look at low-cost materials and potentially substitute a bit of solar cell efficiency, not all that much, so that we can make lower cost materials from the start. And so right now we are seeing a variety of auto manufacturers, Tesla and VW now, and one of the big Chinese companies, ending their use of lithium ion and going to lithium phosphate. And phosphate is a very common low cost material. These are batteries that have about 85% of the capacity of a lithium ion, but dramatically lower cost. And so there's an opportunity to, by looking at the environmental injustice of our current systems, move much more quickly to a lower cost material. In fact, lithium phosphate with a very, very short research time is already a lower cost alternative. And I think those are the examples that we see when we start to put this justice lens, where we don't need to say this will be the most expensive first mover technology. We can move to much more low cost opportunities. And again, I gave the battery example, but there's another example in the area of thin film transparent solar cells for windows, so that office buildings could have solar as the window. And this is, again, a low cost thin film opportunity. So there are certainly going to be some technologies that do need to go through that that White House to rich deployment to poor deployment. But increasingly, I do think that bringing this justice lens allows us to skip that stage and to be much more creative. And again, turnover of building stock, turnover materials are perfect places to again apply that Justice 40 lens, if you will.
Hi. Okay. Hi, my name's Nidra Fears, and I'm with the Greater Chatham Initiative, and we represent a low-income community on Chicago South Side. And I found your two-block electrification to be really fascinating, and just wanted to know, since you've done that, what would you do differently, knowing what you know? And then I wanted to know, what was your payback for the individual property owners and renters, how it benefited them directly, and then the larger community collectively? Because in our community, 40% of our housing stock is three-story walk-up multifamily housing, which 60% of our population lives in, and it was built in the 1920s. And it is vintage 1920. So we'd like to know more about what you know. And that was just a phenomenal example. So thank you so very much for your leadership.
No, thanks so much. And actually, the two parts of your question are really interestingly related. And so what I would have done differently as a physicist, learning what I learned the hard way in this now 6-year process, was that I actively would have begun with the community dialogue in terms of what system do the homeowners or the renters want first, not the technology options. The design of the system on a hardware basis was actually very easy. The design of the homeowners and renters association was much more difficult. We spent well over a year deciding, should the energy that is returned to individual dwellings be done proportional to how much you used before? Should it be based on everyone gets an equal share, and if you want to use more, you have to either pay in? And utilities are generally actively hostile to this setup, and their hostility is mild when it comes to rich homeowners in fancy suburbs, but their hostility is aggressive when it comes to low-income renters in those three-story walk-ups that you described for Chicago and that I lived in for many, many years when I was in Somerville, Massachusetts, just outside of Cambridge. And starting with those agreements would have been where I wish as a physicist I learned much more in the beginning, because once we had the community agreement hammered out, it became much easier to go to the utility and say, well, we demand, in terms of renters' rights, the ability to sell power back or to install a smaller battery because we're going to get a lifeline tariff rate. And it's what a colleague of mine at University of Michigan, Tony Reams, who was the deputy director of Justice 40 at the Department of Energy, really highlighted in his work on heat pumps and other technologies. But I would have started with the community agreement, not with the technical model. And hopefully the versions of the eco block that are now ramping up have learned that lesson from us doing it the hard way and the backwards way, and would have done community design first, hardware design second.
I don't know if it's that good, but hi. I'm thinking a lot about the fact that your presentation is based a lot on these individual home uses, and I'm wondering what the best argument is for that. I think about the efficiencies of utility scale, clean power, and wonder if it's more about resiliency, justice, something else, or it's just that we're in a crisis and we have to do everything. So why are we focused on this specifically? What argument, if we want to do that, would we make?
Well, it's a great question. And actually part of, I would say the biggest topic from this community that I'm working with now is actually a so-called virtual power plants. And that is, if you really want to make clean energy available to renters, that installing larger solar systems and battery systems on, for example, the rooftops of schools, of grocery stores, of other retail property, and making a share of that project available to low-income individuals to offset their utility bill. That's something which is now the rage. What it requires is state-by-state actions, and that means that each one tailors it differently. But I do think this idea that there are economies of scale that become inclusive justice for low-income groups is new to this field, where that's why I started with the talk of highlighting the traditional trickle-down approach. But designing for equity is, I would say, a new lens on clean energy. And it's one that allows you to now think about, oh, we don't need to wait for the most affluent members of the community to try it out, get the benefits, get some great tax incentives. We can actually design from the beginning by installing assets that are available, for example, directly for renters. And in maybe the most radical version, we have a group of economists here at UC Berkeley that are looking to overturn the entire rate structure for utility power and make the rate you pay per kilowatt hour inversely proportional to your income. And there are some interesting arguments for that in terms of deploying solar and energy storage, but the real issue is to shift the burden away from low-income people, the left behind community, and shift the rate base onto affluent community so that they pay the highest rates, so that they can continue to be the front end of installing solar and batteries, but that we actively subsidize low-income Americans, not the other way around. And really that's this virtual power plant and rate reform ideas kind of rolled into their most radical state. Thank you all for listening. And again, I really appreciate how interactive for a remote Zoom-based audience. Very kind of you all. So great luck with the meeting, and I'll be listening in as it goes forward today.